Alright, now is the time to sum everything up and maybe answer the questions that we haven't touched. So we have a site A with the address 192.168.1.0, and I want to connect to site B that is located to the right with the address 172.16.2.0. So when I build a tunnel, I need to have a configuration file on both devices, and the configuration has to match. If it doesn't match, we will not be able to build a tunnel. That's the point number one. The second point I want to make is I want you to actually look at the configuration. And the interface, the graphical interface, might differ, on various vendors, but let's take a look. So on our device number one, we have configuration for both phases. Phase number one, I have enabled SHA-1 as my hash, IS-128 as for my encryption. As for my authentication method, I have chosen pre-shared secret, and it's going to be hello. Diffie-Hellman group, it's going to be 2. There are various groups, and they differ by mathematical process that is going on there. It's kind of complex, and we're not touching that. Key lifetime, we have chosen 86,400 seconds. So basically when the tunnel reaches that amount of seconds, it will be reset and rebuilt if we have active packets going. As for phase number 2, on my A device, on my the device to the left, I specify my local domain as 192.168.1.0, which is site A domain. And the remote encryption domain, I enable 172.16.2.0, which is located right here remotely on the remote side. Alright, so on the second device, I pretty much do the same thing for my phase 1. Everything is the same, and it has to match. If it doesn't match, it's not going to work. And for phase number 2, here we have our first difference. So as for my local encryption domain, I choose site B domain, which is 172.16.2.0. And as for the remote encryption domain, it's going to be the site A's address. So another thing I want to point out is when we have successfully built a tunnel and everything is working fine, the traffic is encrypted, we have to understand whether it's encrypted or clear. So when I send a packet from site A to site B, the traffic gets in clear. It's not encrypted to the point up until it gets to our firewall. When it gets to your firewall, there is a process which encrypts the traffic. The traffic is encrypted when it's leaving the external peer IP, when it's leaving the external interface. The traffic is encrypted. No one else is able to see what's happening inside unless they have a key to check what's happening there. And they don't have it since we have used Diffie-Hellman algorithm to successfully and securely exchange the keys. So the traffic is secured over the link, and it gets to the external interface to our second device, and our second device is able to decrypt the information, and then over its internal link right here, over its internal interface, it is sending the traffic in clear.